Does anybody have a supersized Coke? Nobody has a supersized Coke? How about, I've got a Gatorade here, and I've got a guiding question here. Is this good for you? No. Is this good for you? No, it's not good for you?
Not unless you just ran like 10 miles.
If you've run 10 miles, this is okay? How about a supersized Coke that they've outlawed in Manhattan now? Did you hear that? Manhattan outlawed supersized Cokes. But that's a question that I want you to think about now as we kind of go through this little presentation. Glucose. And if you see the word glucose, that's blood sugar. That is the sugar that's going around in your blood. That is the primary fuel molecule for your body. And is the only fuel molecule for your brain. Your brain burns glucose. Okay? And so when we say burn it, that means we're adding oxygen to it. And this should look familiar. Okay? And there's something left. What is it? What is it? ATP. This is glucose to ATP. That's the big one. That's what you really need to focus on is to, what's the purpose of burning sugar? To get this ATP stuff. You need the ATP stuff. And if you don't get the ATP stuff, then you're going to die. That's still not a good enough answer. Well, why do you need to breathe? Well, you need to get oxygen. You get the oxygen to burn the sugar. You burn the sugar to get the ATP. It's a B plus answer. Maybe a B minus answer. It's not that good of an answer yet. We got to go a little farther. This process, great word, great medical term, glycolysis. Lysis means break apart, explode, tear it apart. Glyco, sugar, breaking apart the sugar. Glycolysis is the first step of glucose metabolism. It happens where? Cytoplasm. Does it require oxygen? No. Water and carbon dioxide. Now I said there's another way pyruvic acid can go. If you are running to a bus and you are out of shape and you got to run 2 blocks, by the time you hit the second block, you're starting to go, you're going into oxygen debt. If you're wheezing and breathing hard, means that you're not getting enough oxygen to keep that aerobic respiration happening. You don't have the ticket to get into the mitochondria. And so some of the pyruvic acid is going to have to go somewhere else. What's its name? Lactic acid. LACTIC, lactic acid. What do you use ATP for? Answer is everything almost, but that's not a very good answer. What do you need? Well, actually write it down in your notebook right now. Write down 5 things you need ATP for. Now look around your table. One person at your table is going to have to speak for your table. I'm going to pick a table at random. I'm going to pick a couple tables, and you're going to give me an answer that hasn't been said yet. So right now at your table, make a decision. Who speaks for your table? Go. Table 1.
Avoiding eye contact. For cell growth and division.
Cell growth and division. Bing, bing, bing. Like that? All right, so you need energy. None of them that were listed in class, by you all, is my number 1 on the list. Okay, that's this next bit. We're now going to go into diffusion, active transport, and membranes. Now, right now on your notebook, try to draw a membrane. Try to draw a membrane. That's something you should do right now at this stage of your class. You should know how to draw a membrane. Try to draw a membrane. I'll give you a key word: phospholipids. So I'll give you a little bit of guilt. You should be able to draw that by now. And here's a phospholipid bilayer. And we know that there's all sorts of other things in there that kind of look like Pac-Man and cholesterol and a few things like that. Should have got that by now. But we abbreviate it often by just drawing a line. Just drawing a line. But that line represents a membrane, and that separates the inside of the cell from the outside of the cell. Separates the extracellular fluid from the intracellular fluid. And if you have a lipid molecule, like testosterone, I'll put the little letter T right here. And this is moving. I want to know, is it going to be able to go through that membrane or not? It's testosterone. You should know it. Yep. Testosterone can move right on through because testosterone is a steroid, which is a lipid, and lipids just go whoop right on through. in a phrase, like dissolves like. And so the cell membrane is lipid. Therefore, any other lipid is just going to go whoop, right on through. All right. We are done with my little presentation. Are there any questions? Caleb? Jason? We are now going to go to the next stage. Here's the deal. Skeletal system. I do not have you learn the bones of the skull. I do not have you learn the bones of the thoracic cage. We are going to focus on calcium homeostasis and osteoporosis. Okay? We are going to have groups of 2, 3, and 4. I don't care if you shuffle within your groups. And I need a couple groups that are willing to, take charge and go over to this table over here. I'd appreciate that very much. And you need to pull apart your tables again and clean off your desks. And I want you to do Model 1 in the next 10 minutes, and then we're going to talk about it. And Caleb and Jason are going to be passing them out.